Okay, good morning. It's today we can
Good
start our
morning,
new
sir.
lesson, huh? And I don't know where is Imasha, Tinuka, and Nemita. Nemita used to be a regular guy. Is he sleeping still? It's I see like him every 30 minutes some new status is coming up. It's never boring with him in WhatsApp. Okay, so anyway, let's jump into our new part now because new part is really important. That's why I was waiting till he is joining from this lesson. It's actually the smallest lesson, one of the smallest lesson in the P1, but definitely a one question is going to come in the paper in this lesson. So I am trying to finish this within like 6 periods. Let's see how it goes. Okay. So I have written what are the questions that I am going to attempt today. Write the topic, all of you. What is the topic? Radians. Okay. Lesson number 7. Radians. That's quite a nice name, no? Radians. So, what is a radian? Now, for example, if I ask you, what's your height? Can someone give me your height? Dinesh, can you comment your height? And Chirango also. That's a bad day. Can I give like a value than a comparison? I need some units. Guess your height. 5'9". Okay. Sabri 7 feet. Okay, nice. Sabri 7 feet. And Dinesh says 5'9". Okay, what about Chiranga? Like, what about Chiranga? Okay. How small are your feet? I don't get it. What do you mean by that? How small are your feet? Okay. Anyway, okay. I get it now. I get it. Okay. Might be he is living some kind of a place like, yeah, Titan, the Titan, moon Titan of Alpha Centauri system. There is a planet called Titan. I think there might be the things, feet might be little small. Okay. So anyway, now Dinesh said 5'9". Oh, Dinesh could have said like 176 centimeters, like that, no? So, uh, here, what do we have? We have two different kinds of measurement systems. When I say, if I say my height, actually this is my height, 5'9", okay? So I am 5'9", and if I say I am 176 centimeters high, I don't know whether they are exactly the same. I think 178 or 79 something. Okay, so it doesn't matter, no. You are okay with it. This is measured in feet and inches. This is measured in centimeters. You know both accounts for the what height. You get that meaning. Or if I ask you, what is the acceleration of a Tesla car? What is the acceleration? Let's say Tesla Roadster. Okay, Tesla Roadster. Uh, So 0 to 60, 0 to 16, 1.9 seconds. Okay, Tesla Roadster has 0 to 60. What does this 0 to 60? 0 to 60 what? 0 to 60 miles per hour. Okay, miles per hour. The car can accelerate from 0 miles per hour to 60 miles per hour within 1.9 seconds. Okay, and the same thing is pronounced another way, 0 to 100 in 1.9 seconds. What does that mean? That means 0 to 100 kilometers per hour. It's the same thing. Okay, it's the same thing. 0 to 100 kilometers per hour under 1.9 seconds. So that's how the acceleration is pronounced. No, sometimes it is pronounced in. We are much familiar with kilometers per hour, but by the way, it is measured mostly in US scenarios. They are saying those in miles per hour. Okay. So there are two different kinds of measurement, but you don't have any issue because you know the unit conversions. Like that, now today we are moving on to new measurement system. It's same as centimeters and feet, same as miles and kilometers, like that. And today we know how to measure angles. No, if I ask you to measure this angle, you can measure it. You can use a product and measure that. How we do 6F and 6G? You are talking about the lesson number 6, trigonometric ratios. Okay, the graphs of sine, cosine, and tan. I think those are the things that you are talking now. Are those? So I will be discussing those in the next beginning of the next lesson, because after this radian lesson, I will be moving into the P2 trigonometric lesson. In that lesson, is the same kind of things going to sometimes repeat. That's why I combine both of the parts and teach you at once. So definitely we need that part. The graphs you should know for definitely, but uh, those two lessons are linked together. So I can smoothly go through it. That's why I keep that part for the next lesson. Okay, let's do that part in the next lesson. So here, to measure a radian, we know how to measure the angles using degrees. We know that our protractor has 180 degrees, so we can keep it between two lines and measure the angle. So similarly, to measure angles, we have a different measurement also rather than degrees. How much is it? That unit is called the radians. Usually, one radian is called. You can draw any circle in your book, okay? And if you take that radius, you can measure that length of the radius, no, of the compass. And if you take the same length in the circumference here, it's a same length in the circumference. You can measure this length by a string thing. You draw a circle in your book. You can measure this length or take this length to a string. Okay, and then you can do what? You can take that length along this circumference, the length of radius. Now there is an angle forming to that value. That value is called how much? That is called 1 radian. Okay, how much is it? Is that thing called? It's called 1 radian. Okay, it's called a 1 radian. So how 1 radian is defined? The angle formed at the center by an arc which is equal to the length of the radius. Okay, again get it? The angle formed at the center of a circle by the length of arc which is equal to the radius. Angle formed at the center by an arc which is length of that arc is equal to the radius. So that part is called a 1 radian. How much is it? 1 radian. Like how much is 1 degree? If you take the whole angle around a point and divide that into 360 parts, that is called how much? 1 degree, no? Space between, if you take the total angular space between a point and divide that into 360 parts, that's called a 1 degree. So like that, how much is going to be the 1 radian? The angle formed at the center when you draw an arc, which is length of that arc is equal to the same radius. Okay, that is called the 1 radian. Now What is the circumference of this circle? Circumference of the circle is equals to 2 phi r. We learned it, no? We learned it in the like grade 7, 8, 9. Okay. Now, if you divide both this circumference by r, now you get what is the angle formed at the center in radians. Okay. If you divide this thing by r, you get the angle formed from the center by radians. So actually, this angle from throughout the circle is how much? 2 phi in radian. So simply we know that 2 phi. In degrees we know 2 phi is equal to how much? 360 degrees. So we can write phi equals how much? 180 degrees. Actually, even though you did not understand everything that I just said, if you can keep remembering this, that's fine. Okay, that means phi in radian is equal to 180 degrees. Okay, like this. How do you keep remembering feet and centimeters? What I does is I keep this what feet rule. I have a feeling that this has 12 inches and this has 30 centimeters. So it is not exactly equal, but I have the feeling that 30 centimeters equal 12 inches. Like that, or 1 feet, no? Like that, what I keep remembering. Radian phi equal 180 degrees. So this is the important part. Using this, we can convert here and there. We can convert degrees to say radians to degrees, like this. If I need to find how much is 90 degrees equal to in radians, how much will be that? What I have to do? I have to first find how much will be 1 degree. To find 1 degree, we can divide this way. 5 divided by 180 will be equal to what? 1 degree. 1 degree in radians. So, sorry, 1 degree. No? So if I need 90 degrees, I just need to multiply both sides by 90 degrees. Okay. So I get how much? 5 divided by 2. I think this is unit conversion. It's not a big deal. You have done this for like so long. So now you can start messing with this question. Okay. So exercise 7a, 1, 2, everything in question number 1. Then question number 2, A, B, D. Then question number 3, A, B, C. Question number 4, B, G, I, O. Question number 5, A and D. Okay. Please start doing those. This is a very small scenario. Still you don't understand, please put in chat. Okay. Still, if you are not understanding what I discussed, what you need to keep is radian, phi radians equals 180 degrees. Okay. Okay, what is said in the question number 7a? In question number 7a, we have, without using a calculator, convert the following angles in radians to degrees. So the angles are given to us in radians. So let's write at first what is our theory part, or what do we take? Phi equals phi in radians equal how much? 180 degrees. So if 1 radian needs in degrees, how much? So you divide both sides by phi. So what do you get? 5 to 5 cancel off. So 1 equals how much? 180 degrees divided by 5. So 1 radian equals how much? Sorry, don't. How much? 1 radian equal 180 degrees divided by 5. Okay. You can divide both ways. If you need to convert this into degrees, you can divide by 180, 5 by 180, then multiply with the given angle or the other way around. Okay. So one way to write radians is you can write RAD, or other way is a little c to the this power. Okay, if you write that little c, that's also called a radian. Okay, that's the notation of the radians. Okay, let's see what is the first one. 5 divided by 20. You need to convert this 5 divided by 20 to degrees. How can you? We know how much is 1 radian. How much is 1 radian? 180 degrees divided by 5. So this much of radians is like this. I would say 5, sorry, 1 coconut equals 80 rupees. So then 5 coconuts, what you do? 80 multiplied by 5, no? So 80 into 5. Like that, 1 is equal to this much. So this much equals how much? 180 divided by 5 into 5 divided by 20. So less whatever the given value here, you have to multiply with 180 divided by 5. Without using the calculator, I think you can do it, no? 5 to 5 cancel off. How much? 20 zeros, so 90. Is it 90? 9, no? 9 degrees. How much? 9 degrees. That's part A. Do them quickly. This is unit conversion, grade 6. The students can do this thing. Okay. Then part B. 5 divided by 15. What you have to do? So just multiply this with how much? 180 divided by 5. So 5 to 5 cancel off. 15 and 180. You know 60 is 4. So 4 into 3, 12. Is it 12? Looks like, no? 12. 12 degrees. What is C? So C to 5 divided by 12. 5 divided by 12. So again multiply with 100 degrees. 80 divided by 5. How much? 5 to 5 cancel off. 180, 12, 6, you can divide by 6. You have 30, you have 2. Again 15. 15 into 5, 75 degrees. D. What is D? 5 divided by 2. 5 divided by 2 means how much? 5 into 180 divided by 5. So you get 90 degrees. Viranga, do you understand this one? Or is it still getting to that point? If you're not understanding, please let me know. So E 75 over 9. You just multiply with 180 divided by 5. So 5 to 5 cancel off. This is going to be 20. 20 into 7. How much? 140 degrees. Niranga, are you there? Put in the chat, because when you unmute, I can't hear. Then 75 divided by 6. You have to do multiply with 180 over 5. 5 to 5 cancel off. 30. 30 into 7. 210 degrees. Okay. Then G 5 by 4. 5 divided by 4 is equal to how much? So you just multiply it 180 divided by 5. 5 to 5 cancel off. This becomes 100 into 45, no? 45 into 5, how much? 90, 180, 225. GH. Namita, do you understand this? Please say yes. So I don't need to. Thank you. That's a good boy. 19 to 270. Okay. How much? 3, 5. 3, 5. 180 divided by 5. 5 to 5 cancel off. How much? Oh, 540 degrees. Okay, we are done. Question number 2, ABD. Question number 2, ABD. Question number 2. What is A? Use the calculator to convert the following angles to degrees. Angles to degrees using your answer, giving your answer to the nearest degrees. First decimal place, no? Okay. So 0.46. 0.46. See, it is given the symbol for radians is how much? See, they have used. So how can we convert this value into degrees? Always we have to find how much is going to be 1 radian. Now we found 1 radian equals how much? 180 divided by 5, no? So if this much of radians, now here all the other questions were given like 5 to 5 cancelled off. In this situation, it's not going to be cancelling off. So it's the same thing we have to do. Just multiply this with 180 divided by 5. So you will have that answer in radians. You can apply this in the calculator. Okay. So 0.46 multiply with 180 over 5. How much it's? 26.36. 26.36 degrees. Okay. They are just asking for first decimal place, no? So 26.4 because it is 5, so you have to go for the upper level. Okay, correct. Then 1 radian. It's easy. How much? 180 divided by 5 into 5, no? So anyway, it's 180 just divided by 5. What is the value? 57.3. 57.3 degrees. Now can you understand? Now is kind of a value, no? It will make more sense also. Now one thing to remember is 5 radians equal 180 degrees, and here we got 1 radian equal actually 57.3 degrees. It will make more sense, like 1 feet equals nearly, not exactly, 30 centimeters, like that. You can take this value, no? That means the angle that forms when we draw those circle. Which circle? I said 1 radian equals the angle formed at the center when you draw an arc which is equal to the length of the radius. So this is called 1 radian. If you measure that angle using a protractor in degrees, you will get how much? 57.3 57.3 degrees. Okay, how much? 57.3 degrees. This also you can remember, no? 57.3. This is also a like approximated value. Why? Phi is not a rational number, it is a irrational number. Why are we using only 100 over 5? Any circle. Hmm. I don't get it. What do you mean by? Oh, yeah. Now you can think this way also. Whatever the value given to you, you can use this now. If you are to find this much, think you have to find this much in degrees. So you instead of 180 over 5, you can write now. We have showed that one radian equal how much? This much, no? So you can write here 57.3. Then also you will get the same thing. 0.46 into 57.3 is equal to how much? 26.4. Is it okay, Namita? Okay, you can use different methods for these conversions, but as a standard, it's always easy because in the future we will be dealing with phi. When we are denoting angles, it will be mostly we should be like it should be very normal notation of feet and notation of centimeters. It's kind of a normal to you like that. uh, so notation, if I write 5 over 6, you get the idea, it is 30 degrees. If I write 5 by 2, you in your mind it should be like this is 90 degrees. So those should be very normal, no? In the top of the question exercise 7a, what is said here, you should know actually. I was going to explain this at the end of this exercise. This 30 degree, 60 degree, 180, 45, 90, 360, those notations in radians, they should be like automatically come into your mind. Once we done with this exercise, it will come to you. Okay, on it word, because we are repeatedly going to use them. Okay, we did B. What about D? Let's just do D. How much? What is D? Square root 3 radians. So for D, they are asking square root 3 radians. You can convert this in two ways. One is, which way? No, you know, if you multiply this 180 by divided by 5, it will be the same as square root 3 multiplied by 57.3. Because both the things are the same. If you divide 180 by 5, you will get this value. So how much is the value? In degrees, square root 3 into 180 over 5. How much? 99.23. 99.2 degrees. Question number 3. Chiranga has asked in any circle. Yes, in any circle, it is the same value. That means now you might have a question. If you draw a circle with the radius 5, and if you draw an arc with the same length 5, the angle here will be, I said, 1 radian, no? So is it the same for if I draw a circle with 10 centimeter radius and the arc will be again 10 centimeters. How much will be this? It's again going to be 1 radian. It's not changing, even the radius changes. The point is, yep, it's like how we define the phi. It's like the phi. So phi was always divide the circumference by its radius, no? That's how we defined. No, diameter. Divide the circumference by the diameter, no? That's how we define the phi. Always when you divide the circumference of a circle with the diameter, you get the same value. It doesn't matter what is the diameter and what that means for a given circle, it doesn't matter. They can be, these values change circle to circle, but the ratio keeps the same. Here also, the ratio keeps the same. Okay, it doesn't change. It's a nice relationship, by the way. You can draw and measure. It will be the same 57.3 degrees for any given radius. Okay, let's move on to question number 3. What is it said in the question number? Use your calculator to write down the value through 3 significant figures following trigonometric functions. Now this is little bit important. What you have to find? Sine 0.5 in radians. This value is given is in radian. Now be very careful when you put that value into the calculator. Okay, see, when you put sine, and if you just put 0.5 and put enter, what you are going to have? 8.7 into, I get the value as 8.7 into 10 to the power minus 3. Did any of you get this value? Okay. Okay. So this is totally wrong. Why? You have, usually we input this, the inputs of these sine cosine ratios are what? In degrees. But think if you are going to apply for the which one? Now let's keep this side for a little bit. What about B? If you for B, they are asking cos square root 2c. Okay. If you put just that way into what you get? Cos square root 2. What are you going to get? Again, you will get the answer. No? So, okay. So the point here is, what you need to do, you have to convert this. That means in the calculator there is option, you have to go press shift, okay, before entering the angle. Here press sine, then before entering the angle, go to press shift and go to mode. Okay, press shift, then press the key mode. In mode you will see math IO, linear IO, degrees, and for the question number 4 it will be shown as radians here. Okay, it will be showing you as radians, and 5th radian, 6th fifth, and so you have to convert this your units into radians. So press 4. Now you can see in the top of your calculator here inside there will be R sign. Okay, there will be a R. Dinush has calculated manually. No need to calculate manually. There is option available in the calculator. Okay, so what you need to do is change your mode. So again, shift mode, then you have lot of selections. You can switch between degrees and radius. If you press number 3, you can see in the calculator up here, it is the D, letter D, you can see. If you are in, you can always, you can look at the keypad and see. I think even though the calculator is different, the notation will be the same. The same letters. I don't think you need a EFX 991 plus. What's your calculator, Chiranga? Doesn't it have shift and mode? I think it will. Okay. So, or else you can use the. Told you the. Did I told you this calculator about this? What I am using in my mobile? It's really easy in this one. Okay. You can download this calculator to your phone. It's almost like the this one. Okay. Fix 100 ms. 100 ms. I don't know about those ones. It has nothing. Nothing means sometimes this might be the case. Okay. FX991 plus ES. That's the one I am using. Okay, this might be the situation. If you don't press the shift, now think. Okay, if you just press more on, you are going to get different setup. What are the things? One is comp, second is complex, third is stat, like that. No, don't do that. You press AC, you press shift and then press mode. Okay, after pressing shift and mode, you will get this selection between math IO, degrees and radians. Okay. Yes. Okay. Chiranga also has the same thing. So no, EX, no. This is ES. So anyway, I don't think I think any scientific calculator has this function to switch between radians and degrees. It's not a big deal. It's just including this one. Okay. Uh, Somehow that functionality will be there. Okay. Yeah, search a bit, then you will know. You know what to do when you are stuck in a game. You search for 1,000 scenarios to go for the next step. Okay, so just google your calculator brand and then how to convert into radians. That it's that simple. Okay, don't worry. I know, but the students are, "Oh, no, I can't find it, so I just give it up." Don't be like that. Okay, so make sure your inputs are in radians. You can see up here whether it is a radians or degrees. It will denote in DOR. If you put shift mode then press 4, it will turn to radians. Okay. Okay, or if not, you can go to shift mode again. You can convert 3. Okay, shift mode 3, then you will go back to degrees. So learn to switch between those two scenarios. In the future, this will be much needed. Okay, you are going to get completely different, completely wrong answers if you don't select the correct mode. So what you have to put here is put it in radians. So sine, then shift mode number 4, and you have the R here. When you have the R, you can put how much? 0.5. 0.5. So what's the value? Value will be equals to 0.47. Okay, they are asking for 3 decimal places, so like 3 significant figures. Okay, this is enough. 0.479. Okay, 0.479. What is the next one? Cos square root 2 in radians. So you just press cos. Once you turn it into radians, it will not go back until you are turning it back into degrees. Okay, keep it that in mind. Okay. Okay, now I think everyone is fine with that. Is it okay? How much is? Press cos and check the your unit sign radians. Then just put square root 2. It will be, the answer will be 1.556. 1 point, sorry, 0 point, how much? 0.156. That might be the answer. 0.156, no, because they're asking for three significant figures. So I just converted to third one. Yes, then what is the next one? Next one is C. Part C, tan 1.5. So it's the same thing. Tan 1.05. 1.05. 1.74. 1.74. 1.74. When they are asking to switch between this number of decimal points and significant figures, sometimes it's tricky, you know. Keep remembering writing in significant figures is sometimes a headache. But if they're asking for like this decimal place, it's really easy. Make you answer to first decimal place, second decimal place. It's okay. But when they're asking for significant figures, sometimes it changes the number of decimal places. Okay, question number A, B, C are done. Now question number 4, BGIO. This is a very small scenario, okay? We are doing grade 6 things. BGIO. Please, one of you tell your friends Tinuka and Imasha to how to convert these radians into degrees. This is very fundamental, but it's going to be very much needed for the next lessons. It's really hard when you miss the first day of a lesson to grab the rest. Question number 4A. What I have to do? Convert the following angles into radians. Giving your answers as simplest from 5 shown in the example 2. So the point is you can't use the calculator for this one. It's like without using the calculator converting this. What is B? I would take degree 10 degrees. So if I go back, what is the relationship that I has in my mind? Phi equals 180 degrees. Okay. What is in my mind is phi equals 180 degrees. That's the only thing. So if I need to convert degrees into phi's, radians, so what I do is I divide both sides by 180. So I get 1 degree equals how much? 1 degree equals phi divided by 180. So if I need 5 degrees, I just multiply given value of degrees with phi divided by 180. The other way we did it so far, no? To find 10 degrees, what you have to do? So I just multiply 10 degrees with phi over 180. So 0 to 0 cancel off. Answer will be phi divided by 18. Okay. So it's the other way. To convert radians to degrees, we multiplied with how much? 180 divided by 5. Now the reverse. 5 divided by 180. Next one, G. 75 degrees. How can you convert? Into 5 over 180. what are the, it looks like getting divided by 5, no? So if you divide by 15, it is easy, no? 15, there are 5 15s here. How many? 64, 12. So the answer is 5 divided by 12. Answer will be 5 divided by 12. I am going a little bit faster. Please let me know if it is not making sense to you. Okay. I think these are not that harder to understand. Then I'm just doing some sums to save the time. But if you are not confident, please go through all the sums of this lesson, exercise 7A. Okay, it will not take that long. 112.5 into 5 divided by 180. Now you should be familiar with the multiples also of 180. No, if you divide that into 4 parts, you will have 45. If you divide this again, it's going to be 22.5. So the point is both are divisible by 22.5. If you divide this by 22.5 and dividing both this and this by 22.5. Yes, Dinesh, you can go. Okay, because I think you are meaning by next lesson means next part of the lesson. Okay, arc length and the uh, areas, sectors, and segment. Is that okay? So it's okay to go for them because for sure there is going to come a question on this arc length and the sectors. Okay, just jump onto those, read, and go through them. Is it okay to add radians besides the answer? That means you write here at RAD. Yeah, you should do it. Okay, that's my guide. You should do it. Write it. Okay, you should write RAD here. Okay, yeah, or you can just put that little c. Here, when you divide both up and down by 22.5, you get 5 here. How much here? It's going to be 8. So the answer is 5 divided by 8 in radians. Okay. O, part O. O, 315 degrees into 5 divided by 180. So I feel like we can divide both up and down by 45, no? If you divide this by 45, you will have 4. This by, you will have 7. So 7 5 divided by 4 radians. Look at the question number 5 and try to do that. I'll give you a little time if you need to write this also. What's the next part? Question number 5, use your calculator to convert the following angles to radians. So 50 degrees in how much? In radians. So we have to divide by 180 and multiply by how much? 60, no? Sorry, 5. A and D. So again, same thing. 160 degrees into 5 divided by 180. Put in the calculator, what are the answers? What are the answers you are getting? 50 into 5 over 180. 0.87 radians. 0. How much? 87 radians. How much for this one? 2.79. 2.79 radians. These are the two answers. Okay, I think everyone is fine with this unit conversion. Get it simple. What do we have here? Oh, name it. Do you have pizza these days to eat? We even don't have chupang coming on the road. Okay, so now jump into the next part, arc length. No, how to get the arc length? This is something you already know. You know how to find the arc length. Given arc length, what is an arc? It's part of the circle. Part of a circle is called an arc. So if I ask you to find this, oh my God, who draw this circle? Yep. If I ask you to find this length here, I take it as capital L, simple L. How do you get this length? If you know the radius and if you know the angle in degrees, you know how to get it. How to get it? Theta divided by 360 into 2 phi r, because the circumference is taken by 2 phi r. 2 phi r into theta over 360. Okay. Now think, you are given this theta not in degrees. If it is given in radians, is this equation true? No, it can't be true. Why? We using this part, actually we are finding how much of the circle is it, no? So if it is this theta is given in radians, what we have to do? First we have to convert this thing into what? Degrees. How do we convert radians into degrees? We learned phi equals 180. So convert this radians into degrees. What we have to do is multiply with 180 over 5. This will give us what? In degrees. And then we know we have to divide that by 360 and again into 2 phi r. No? Now if this is given in degrees, it doesn't matter. We can easily use this equation. Okay. But if it is given in radians, we have to convert that radians into degrees first, then divide by 360, then into 2 pi r. If I rearrange this a little bit, this equation is going to be like theta into 2 phi r, and everything here comes under, no? Sorry, there is 180 also. 180 into 2 phi r divided by 360 into 5. What happens? This 5 to 5 cancel though. Yeah, 2 into 180 is 360. So this 360 also cancel out. So we end up with theta times r. Okay. So actually this was the equation for what? This L, no? So the arc length we can easily get by this equation. This is written as L equals r theta. Arc length equals radius times the angle formed in the sector. Okay. This word, sometimes this word might be new to you. I don't think it is new. Sector. What is a sector? It's a piece of a circle which is bounded by two radius and the circumference. Always keep in mind, to be a sector, you need two radius. It's like a pizza, circular pizza part. Okay, not like the ones that Nimita is showing us now. Okay, so it should be a circular pizza. Okay, sector is called a part of the circle bounded by two radius. Okay, so now to get the length of the arc length of a circle, we can easily use this r theta, but this theta should be measured in what? Should be measured in radians. Okay, if you are to use this equation, make sure always you use theta is in radius. If not the case, it's going to be wrong. Hope you understood. Okay, only thing you need to get here is what? You can find the sector or the arc length of a circle by using this equation L equals r theta. Now for today, how many things we learn new? Two things. One is this phi equals 180 degrees or phi equals 57 something, no, 57.3 degrees, and this L equals r theta. Using this, now we can do a lot of things. So yep, you can draw this figure and mark this. So actually, in my teaching method, I know I'm not giving you a lot of notes, no? So it's your duty when I discuss a theory part to note down the essential theory parts. Okay, I am a little bit following the order of the university. Why? The university we never get notes. We are never asked to write anything. You can just, if you want, you can just watch or at the board for over the lessons. You lecturer never asks you to write any single letter. Okay, but as students, it's our duty to pick up the important points. What are the new points? So here you can copy down if you want everything. Okay, like that. So what I am not stressing you to write down everything is because everything is in very clearly given in your textbooks. So these textbooks, I really appreciate the way that IAS textbooks are, okay, rather than the O levels. IAS textbooks are really good. If you think about local syllabus, there are no textbooks at all. Okay. Whatever the tuition master teaches us, we learn. We don't know. We don't have a textbook. Only a syllabus is there, but syllabus is kind of like topics. We don't know how deep the question is coming. Only we get the sense by doing some past papers. But in IAS, Pearson syllabus, A-level textbooks are really good. Okay, so you have the theories, everything. So make sure you know how to pick the theory parts when they are needed. The summaries of the lessons really helpful. Okay, if you go through the summary of the lesson, you can remember everything. They have given nice summary. Okay, let's jump into the exercise 7b. We got 10 minutes left. Okay, so from today onwards I will put the things that I am going to discuss in the next class. Okay, so please go through them. Now I have given some questions, so I will continue discussing this in the next day. Like that, you can yourself try to go through them a little bit, like 10 minutes, 15 minutes, at least half an hour. Then it will be really helpful for you to understand the things I am discussing in the next class. Okay, let's try to do one or two of these. Exercise 7b, question number 1. A, what they are asking. 7b. Question number 1, A1. An arc AB of a circle, center O, radius R, substantial angle theta in radians at the O. Length of AB is L. So find L when R and theta are this. So what is the equation? L equals R theta. Only thing is theta should be in radians. So R6, theta 0.45. R equals 6, theta equals 0.45. So how much is length? Length equals 6 into 0.45. How much are we getting? 0.9, 9 into 3, 2.7. 2.7. Is it given in centimeters? Yes. So the answer is 2.7 centimeters. If we draw a little diagram here, it's going to say how much? The angle here will be 0.45 in radians. The radius is 6. This length is going to be 2.7. What about the part 3? L equals how much? R equals 20 and theta equals 3508. 20 times 3508. How much are we getting? Can divide 20. We got 2. We got 5. So 15, 5 over 2. You can get a nice answer. 15, shift 5. 23.56. So the arc length is going to be 23.56 degrees. Sorry, centimeters. Okay. Arc length equals this much. It's making the subject, all these questions. The first question is getting familiar with this equation. I don't think it's a big deal, but to make the subject. Part B3. What is in part B3? Finding R. They are asking R when how much? L equals 1.55 and theta equals how much? 5 over 12. Yes, let's find the radius. So we can find L equals R theta in the place of L. 1.55 equals radius times that much. 5 divided by 2. So 5 to 5 cancel off. If you make R as the subject, it will be 1.5. It's like 3.3 over 2. No? So you can write 3 over 2 here. So 6, 18, 18 divided by 5. 18 over 5. If you go deeper, you can have 3.6 centimeters. Next one will be part C, question number 3. So what they asking theta when r equals square root 3 and l equals square root 12. How to get L equals r theta? L is square root 12, r is square root 3 into theta. How much is theta? If you divide it, you will have square root 4, no? Square root 4 is how much? 2. So 2 radians. Theta will be equals to how much? 2 radians. Does it make sense to you? Think so, no? Hope today's lesson is understandable to you. So anything that you need to clear before I am done with today's questions? I will be discussing these and some other questions next day. Do you need more explanations? No. Sunal, I think they are clear, no? So I request you to go through these questions and I will put all the questions that I am going to discuss in this lesson in the chat WhatsApp group. Try to do them before the next class. And see you. Thank you very much. And see you Monday.
Thank you, sir.